Welcome to Lesson 1, Graph Exponential Functions. Our objectives are to understand key characteristics and points of exponential functions, and then to graph both the exponential and the growth and decay function using transformations. Below here are some examples of parent functions of exponential growth and exponential decay. Notice with the growth that you grow slowly initially, and then you increase at a more rapid speed. This is exponential growth. Compare it to a linear function where you grow at a constant rate of change. Look at the decay function now. You decay very rapidly initially and then you fall off over time. Also notice one key characteristic of both these functions. Parent functions will always go through this point 0, 1. So in order to graph a function, a parent function, we always want to plot this point 0, 1, and then we want to plot a point to the left and to the right of that. So we would look at -1 for x and +1. Also notice that the end behavior of these functions, if you look down here where it gets close to 0 for exponential decay and exponential growth, the function appears to be going towards 0. However, will not actually ever hit 0. If you remember what happens here, from previous lessons when we looked at rational functions, there's an asymptote, a horizontal asymptote. So our function will get really close to 0, but it'll never cross it. You can use the axes here, the x-axis as a guideline. All right, so here's our parent function, y equals b to the x. We can have any base there. It's still considered a parent function. It'll just change the shape of it just a little bit. One thing is that when we have exponential growth, the base can be any number as long as it's greater than or equal to 1. So our base could be 2, 3, 4, 5. It could even be 6.5, 7.2. Here's some examples. Y equals 2 to the x, y equals 4 to the x. Those will all resemble the exponential growth function. Exponential decay, on the other hand, says that a base can be any number that is greater than 0 but less than 1. In other words, a fraction, like 1/2, 1/3, 1/4. Here's some examples. Y equals 1/2 to the x, y equals 1/4 to the x, etc. Those will form exponential decay functions. Let's practice graphing a couple of parent functions. Here's our first one, y equals 2 to the x. Let's go ahead and plot our key points that we talked about earlier. So remember, we always want to plot 0, and then we want to go -1 and +1 on either direction. So I'm going to write -1, 0, +1. Let's go ahead and see what happens when we take 2 to the -1. Remember your properties of exponents. If you raise a number to a negative power, you can make the power turn positive by flipping the number to the bottom or to the top. In this case, we would flip it to the bottom. So now we have 1 over 2 to the +1 power, which is just going to be 1/2. 2 to the 0, anything to the 0 power is always 1. 2 to the 1, anything to the first power is always itself. Now we're ready to graph. Before we graph, I'm going to go ahead and put in the horizontal asymptote that we talked about. Remember that this is a parent function, so the horizontal asymptote will be here where y equals 0. Now let's plot our points. We have -1, 1/2, 0, 1, and 1, 2 right here. All you need are these 3 points to help you with your curve. From here you can sketch your function up and you can sketch your function down. And remember that this function is going to get closer and closer to this asymptote, but it's never going to cross it. So let's think about that in terms of domain and range. Remember that domain is all the x values in this function. And our domain, well, this function is going to go to the left forever, and it's also going to go up and to the right forever. So our domain is going to be -infinity to +infinity. So think about the range. Well, our range is going to go from 0, but it's not actually going to ever hit 0, so we use a parenthesis. And then it's going to go up, 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 up forever towards +infinity. This is our domain and range for all parent functions. Let's now try to graph this decay function. So we're going to use our same key points, -1, 0, 1, and we're going to plug that in. So we have 1/2 to the -1. Again, we're going to a negative power, so we can flip our fraction and we get 2/1, or just 2, to the +1, which is just 2. 1/2 to the 0 is going to be 1, and 1/2 to the first power is just itself, 1/2. Again, remember that we have our horizontal asymptote here at y equals 0. You can sketch that in. And then we can plot our points. We have -1, 2, 0, 1, and 1, 1/2. And you can see now we have our curve. And it looks just like 2 to the x, only now it's decaying from left to right instead of growing. If we write our domain and range, you will see that we end up with the exact same domain and range. Our domain represents, again, all the x values. So that would go from -infinity to +infinity. Our range then still goes from 0 up. So we always write smallest to greatest, so we go from 0 to +infinity. Notice again I'm using a parenthesis instead of a bracket because it will never hit the 0. Let's look at transformations to the parent functions. Hopefully by now these are starting to look very familiar to you. A in the front is the same as all the A's in the front. This is going to be a stretch or shrink. And if you remember that it's a stretch if the number is greater than 1, and it's a shrink if it's a fraction. If we have a negative in front of the A, or a negative A value, I should say, then you can think of that as a reflection. And that's always a reflection when you put a negative with the stretch or shrink. The key here is that it's going to reflect over the x-axis. How about H? Well, H is the same as it's always been. It's paired with the x, so that means it's going to shift along the x-axis, which means that's going to shift left or right. So horizontally. And remember that it shifts the opposite direction since it's in with x and x is not equal to it. So if we have x minus 2, it's going to shift to the right 2, not to the left. And then our k on the end goes along with the y. So that shifts up and down or vertically. And these transformations are transformations that you have already seen now over and over again since the start when you were doing linear functions. Let's look at what these transformations do graphically. We're going to start with our parent function over here, y equals 2 to the x. Notice the key point. Well, what happens if we put a stretch of 3 in front? What do you think is going to happen? Make a prediction. Remember, when you put a 3, a number greater than 1, it's going to stretch up. So the blue line represents a steeper slope. Notice that everything is multiplied by 3. So we no longer have this key point here of 0, 1. It's now moved up to 0, 3 because it was multiplied, the 1 was multiplied by 3. All right, let's look at a different transformation. How about if we put a 1/3 in the front? Well, remember that if we have a fraction, that's a shrink. And now look at what has happened. Our graph is less steep, and it no longer goes through our key point. In fact, it goes through 1/3. Okay, moving along. What happens if we put a negative? We said it reflected over the x-axis. What does that look like? That's what this looks like. This now goes through 0, -1 instead of +1. Let's try x minus 3. Remember that we shift the opposite direction when we are shifting h. So make a prediction. Where is this going to go? Notice that instead of being over here at 0, 1, we're now over here at 3, 1. It shifted to the right 3. So I'm always looking at this key point to see how this transformation has affected my graph. Okay, let's just try 2 to the x and then a minus 3. So this is not with the x, this is actually with the y. Well, remember that these shift in the same direction. So minus 3 means it will shift down here to 0, negative 2. Now you might be asking yourself, well, why isn't it 0, negative 3? Well, think about this. If we started at 0, 1, and we took the 1 and we shifted down 3, let's count. 1 takes us to 0, 2 takes us to negative 1, and 3 takes us to negative 2. So literally we just did 1 minus 3 because we shifted down 3. Okay, let's change parent functions. Let's look at a decay function right here. And again, here's our key point, 0, 1. What happens if we make it negative? Same thing, reflects over the axes, the x-axis. What happens if we put a stretch? Notice, gets steeper. Let's keep going. What happens if we have x plus 3? So we have a plus 3 for h. Well, hopefully you're saying we'll shift to the left 3, and we do in green. How about if we put a plus 3 on the end so it's not with the x? Notice that we shift up 3. Okay, now that you understand how all these transformations look, let's try to graph a few on our own. Let's try this, y equals 3 raised to the x plus 2. Well, hopefully right now you're saying that's a shift left of 2. So we know what the parent looks like, so that whole thing will shift to the left too. But let's go ahead and plug in key points to make sure we have the right points. Well, if we plug that in, we get 3 raised to the 1 plus 2, which, or I should say negative 1 plus 2. So that leaves us with 3 to the 1, which is just 3. In this case, now we have 3 raised to the 0 plus 2, which is just 3 to the second power, which is 9. And then we have 3 to the 1 plus 2, which is 3 to the third power, which is 27. And we can see that's not going to fit on our graph. All right, remember that we have our asymptote, and our asymptote will still be the same because all we're doing is shifting to the left or the right. We're not shifting up or down. So our asymptote will still be here at y equals 0. Let's plot our new points here. We have negative 1, 3. We have 0, 9. And then we're going to have 1, 27. So that's way up here. If we connect these points, the graph will look a little bit like this. This is a very rough sketch. Now what about the fact that we shifted to the left too? Well, instead of having our point here at 0, 1, we shifted over 2. But notice I didn't put negative 2 in here. If I were to put a negative 2 in here, we would have 3 raised to the negative 2 plus 2, which is just 0, so we would get 1. At negative 2, we should have a point here at negative 2, 1. Okay, let's try this graph here. Notice that on this graph we're going to have a stretch of 2, and we're going to shift down of 4. So our asymptote isn't going to be here at y equals 0 anymore. It's going to be down at y equals negative 4. And this is going to be very important that you always plug in the asymptote so that you have a guide. Y equals negative 4. The key then for you is to know that whenever you have a shift up or down, that will always impact the asymptote. A stretch or shrink does not, and a reflection does not, and a shift left or right does not either. Let's plug in some key points so we can graph this. Let's start with negative 1. Okay, so we would have 2 times 3 to the negative 1 minus 4. Be very careful to follow your order of operations. We do the exponents first. 3 to the negative 1 is the same thing as 1 over 3, 3 to the 1, because the negative 1 changes to positive when we flip this. And then we have minus 4 out here. Well, 2 times 1/3 is going to be equal to 2/3. And if we subtract 4, and you can do that in your calculator, you can do 2 divided by 3. In fact, let's go ahead and put that in our calculator so you can see. If we take 2 and we divide it by 3, that equals 0.666667. And then if we subtract, so minus 4 from that, we end up with negative 3.3 approximately. So negative 3.3. All right, let's go ahead and try another point. Let's look at the 0. So what happens if we take 3 to the 0? So what we have here is 2 times 3 to the 0 minus 4. 3 to the 0 is just 1. And 2 times 1 is 2. And 2 minus 4 is negative 2. Finally, let's do a positive 1. So we have 2 times 3 to the 1 minus 4. Anything to the 1 power is itself. So now we have 2 times 3, which is 6, minus 4 is positive 2. Now we can graph. So our first point is here, it's down here a little bit, but it's negative 1, negative 3.3. So that's right about here. Our second point is at 0, 3. So let's go ahead and graph that point. And, sorry, it's at 0, negative 2, right down here. I was looking at the wrong number. And then we have 1, 2, which is right here. Okay, now we are ready to connect the points. So our graph, if we follow our asymptote, will look something like this. And this is why it's so important to always know where the asymptote is so we know how far down to go before we stop. So remember, the only time our asymptote changes from y equals 0 to y equals something else is if we have a change here, a shift down or up on the end. All right, let's move on to our last graphs. These are our decay functions because they have fractions. So we're going to go ahead and graph our key points here. It looks like this negative, all we're going to have is a reflection. So let's see what that looks like with our 3 initial key points. Well, negative 1, 3 to the negative 1. Well, in this case, we take the 1/3 to the negative 1 first, so we flip it. So we get negative 3 to the 1 power, which is just negative 3. Okay, in this one now we have negative times 1/3 to the 0. Anything to the 0 is 1, so that leaves us with negative 1. And then in the last one, we have a negative times a 1/3 to the 1. 1/3 to the 1 is still 1/3, so we're left with negative 1/3. Okay, remember what we talked about. Always sketch in your asymptote before you graph. So we don't have any shifts up or down, so our asymptote is still going to be y equals 0. Graphing these points, we get negative 1, negative 3, 0, negative 1, and 1, negative 1/3. Look where this graph is. This graph is now below the asymptote because there's a reflection. Instead of being up above, decaying, we are now down below. It reflected over the x-axis. Let's sketch our final graph. Notice that I went ahead and put in my asymptote at y equals 0 because we don't have any shift up or down, so I know that it's still going to be at y equals 0. Now remember that our original key points are negative 1, 0, 1. But this transformation up here, x plus 1, means we shift everything to the left 1. So instead of doing a negative 1, I'm going to shift that to the left to negative 2. Instead of doing a 0, I'm going to shift that to the left to negative 1. And instead of doing a 1, I'm going to shift that to 0. That will just help my graph look better. All right, we're ready to plug those in. So 1/3. And then negative 2 plus 1 is just negative 1. That means I can flip this to 3/1, or just 3, now to the positive 1, which is 3. Okay, this one, negative 1 plus 1 would give me 0, and anything to the 0 power is 1. And the final point, 0 plus 1 is 1, so 1/3 to the 1 is just 1/3. Easy to graph. I go to negative 2, 3, plot my point, negative 1, 1, and plot my point, and then 0, 1/3 is just about here. If I connect these lines, you can see that I have a decay function that shifted my key point from 0, 1 over here to negative 1, 1. And I could have still graphed it with my original 3 key points, but it would just be hard to have a good sketch. And that concludes our lesson on graphing exponential functions. You've already had some experience graphing with various types of functions, so this should go fairly quickly for you. The key for you is to recognize that you have a decay function when it's a fraction and a growth function when it's not, when it's a number that's 1 or greater. You should be able to recognize the key transformations, which haven't changed since we originally used those. We still have our stretch, our shift left and right, our shift up and down, as well as our negative, which means a reflection over the x-axis. In the end, you can always just use key points to help you graph these. I used 3, but in this case 4. You can use as many as you want with a minimum of 3 that will help you graph these functions. The final thing that I want you to get out of this lesson, a measure of success, would be for you to recognize when you change the horizontal asymptote. The only time you change it is when you shift vertically. When you have a value in here for k, that value will always be your new asymptote. So if this is plus 10, your asymptote is going to be y equals 10. If this is minus 8, your asymptote will be at y equals minus 8. So this is very important. Anytime you shift vertically, that will change your asymptote. And that concludes our lesson.